Hello and welcome back. We will pick up where we left off looking at this example. So we had an example where we looked at course evaluations for male and female professors, and we wanted to see if there is a difference in the average, in the mean rating. So we did this. We wrote down our symbolic claim that there is a difference in the means. Our test statistic and our p-values were calculated for us using StatCrunch. We had all of this, and our test statistic and our p-values are calculated for us. We see that our p-value is in fact greater than the significance level, our significance alpha. So we fail to reject. Since the p-value is large, we do not think that this would be an unusual sample, so there's nothing to suggest that anything was really going on. So our conclusion would be that there is not enough evidence to suggest that there is a difference between male and female professor evaluations. So this is what we concluded using our p-values. However, we can also do all of this using a confidence interval. So let me come back, and before I show you the confidence intervals, one thing I want to point out is that the degrees of freedom that they used for this hypothesis test was 19.06. Now, we had normally seen that the degrees of freedom in a test should be one less than the sample size, and the sample sizes were either 12 or 15. But 19 is certainly not one less than, for instance, 12. So how did they come up with this? Well, they used a pretty big formula for this, and it means that the computer can do this a lot more accurately than just choosing the degree of freedom to be quite small. So let us go to statistics again. We are looking at T statistics. We have two samples, and we have all the data values already given in these two columns. So we have female and male professors. We do not want to pool our variances because we do not know if the standard deviations are going to be the same. And instead of performing a hypothesis test, I want to create a confidence interval. And our level of confidence should be 95%, 0.95, because our significance level is 0.05. So 1 minus 0.05 gives us our confidence interval. And then I will also include the confidence interval plot and the summary statistics without changing anything else. We'll compute this, and we will see that we have the same summary statistics, and our confidence interval is given by the lower limit and the upper limit. The lower limit is negative 0.5, let's say 3. I'll just round that to 2 decimal places. So negative 0.53. And what we're doing is we're testing the difference between the two means, and the upper limit will be 0.27. So when we look at this confidence interval, and again we can display it graphically as they do here. It's not a super nice picture, but we can see that it goes all the way from over here up to here, and the point is 0 is contained in this confidence interval. So the difference between mu1 and mu2, the difference between the two means could be 0. So our conclusion is would be that it could be the case that mu1 is equal to mu2, as in it could be the case that the two population means, the average scores on the professor evaluations, are the same, which is exactly this conclusion. There isn't enough evidence to suggest that there's a difference between them. We are 95% confident that 0 could be the difference between the two means. So our conclusion is in fact the same. We draw the same conclusion using both methods, which should be the case. It shouldn't matter which method you choose. We should draw the same conclusions from the same data set. So let's look at one more example. So here we are comparing how much pop or soda is contained in some cans. So we took 36 cans of Coke and 36 cans of Pepsi, and we looked at how much liquid was contained in them. So for the Coke, there was a mean of 12.19 ounces, and for the Pepsi, there was a mean of 12.29. So this might suggest that there's a little bit more Pepsi in these cans than there is Coke. We also need the standard deviations, 0.11 and 0.09, to be able to do our hypothesis testing. So can we conclude that there is less Coke in an average can than Pepsi? And then it gives us our significance level right here. So let's run through this. Our claim is that there is less Coke. Let's see here. Let's say in an average can, than Pepsi. So if we call the average liquid in a can of Coke to be mu1, and sorry, the mean and then the mean liquid in a can of Pepsi, our symbolic claims would be that there is less Coke than there is Pepsi. So mean 1 is going to be less than mean 2. Our null and alternative hypotheses, so H0, will be that they are in fact equal, and our alternative hypothesis will be our claim up here that mu1 is in fact less than mu2. And our significance level, alpha, is going to be 0.05. So again, we'll need to come up with our test statistic and our p-value. So if we come to StatCrunch, we can come to statistics. Again, we are testing population means, so we'll be using the t statistics. We have 2 samples, but now we don't have the actual data values. We don't know the amount of liquid in all of these cans, so we're just going to have to use summary, which when you are doing the summary, what will they ask for? They'll ask for the mean. So for instance, for the Coke, that was 12.19. The standard deviation for the Coke was 0.11 ounces, and there were 36 cans that we tested. There were, in sample 2, for Pepsi, that average was 12.29. The sample standard deviation is 0.09, and the sample size again was 36. We will not pool our variances because we'll not assume the same standard deviation for both Pepsi and Coke. And let's perform our hypothesis test. So again, the null hypothesis is that the 2 values are equal, and the alternative hypothesis should be that the Coke is less than the Pepsi, as in mu1 minus mu2, mu1 being the mean for the Coke minus the mean for the Pepsi, should be less than 0 if we're taking a number minus a bigger number, we should get a negative number. And again, I will include the summary statistics and the p-value plot just so I can create some graphs to look at. And let's compute this. So what we see when we look at the populations, our mean and our standard deviations are listed there as we type them in. The degrees of freedom in this case is going to be over 67, which again does not look like our sample size minus 1, but the computer is using a much more complicated formula. We have our test statistic and our p-value. So our test statistic is going to be negative 4.22 if we round, and our p-value is actually going to be really small, and our p-value is going to be less than 0.0001, which means that since the p-value is less than the significance level, we do reject our null hypothesis. And if we can reject our null hypothesis, that means that the mean amount of liquid in these cans are not the same. So that means that our alternative hypothesis should be accepted. So our conclusion is that there is sufficient evidence to suggest cans of Coke have less liquid on average. Cool. Now, as just a quick aside, how much less? Well, the Coke has 12.19 ounces, and the Pepsi on average, the mean is 12.29. A tenth of an ounce is not going to be very significant, as in practically significant. But there is statistical significance, and enough to say that we would expect it to have less. The very last thing that we'll do is to do the same thing, except for we will create a confidence interval. So again, we're looking at means, so we're looking at t statistics, 2 samples, and we only have the summaries this time. So the means were 12.19, the standard deviation was 0.11, and we had 36 cans of Coke. It had, on average, 12.29 ounces of Pepsi with a standard deviation of 0.09 and 36 cans of Pepsi. We will not pool our variances, and we will create a confidence interval. And again, the confidence level is 0.95, since our significance level is 0.05. They should add up to 1. And let's create both the summary statistics and the confidence interval plot. And we will create this. So our confidence interval is now here. So this will be negative point, let's say 1.5 and negative 0.05. So negative 0.15 and negative 0.05. So what conclusion can we draw from this? Well, first of all, 0 is not between 2 negative numbers, so we can reject our null hypothesis. And moreover, what can we say? Well, mu1 minus mu2, we are confident that it's always going to be a negative number, since it's between 2 negative numbers. So if mu1 minus mu2 is always going to be negative, that means that mu1 is less than mu2. So the average Coke in a can is going to be less than the average Pepsi in a can. And we draw the same conclusion as we did before.